to 0.98 multiplied to
minus 0.3n instead of 1 for
Will, how do you determine the one? Just determine the percentages.
Okay, I get it. I understand. I know.
We're in the most closest point.
Okay.
What's 2 divided by 3? 2 divided by 3 is 0.66. I think I'm doing this one. Wait, because
what is the square root of
so I got here.
We have calculators back there too,
So
with square root functions.
Oh, really?
Uh-huh.
1 minus q. Oh, that had something different. It was like
Substitution?
kind of. Yeah, kind of like you have p equals that minus q, and then I don't know.
I'm gonna.
What I do with those is I just do write that twice.
But I'm gonna try
They don't
explain.
have that.
Just to be
4, 8, 9, 8, 9, 7, 9, 4, 8, 5, 5, 6, 6, 3, 2,
In the product.
Oh yeah, do you want to sit? No, I think we got it, but I don't know why people are having trouble with it.
So what's P equal?
P equals 0.24 and Q equals 0.76.
So 0.24 is what?
Is the frequency of the dominant trait, and 0.76.
Where did you get that 0.24?
Also, for the question says
The recessive. Q is the frequency of the recessive.
okay, let me check that. Okay.
So 0.76 is the frequency of the dominant allele, while 0.24 is
Divided by 100.
Where did you get that 24%?
well, we knew that there were 20 non-tasters, so just from
20?
There were 12 non-tasters.
Okay.
Sorry, and there would be 24. So that'd be 24 alleles of the recessive allele, and then we divided that by 100, which is the population times 2.
Is it possible for any of the tasters to carry a recessive allele?
so that's not taking into account.
So what did you define? What is 0.24? 0.24 is something.
It's the non-tasters.
What is non-tasters?
The
Homozygous recessive, but that's not
So what is homozygous? What is homozygous recessive?
little t.
Do we have a way to? Do we have a variable that represents homozygous recessive? Is it Q or Q squared?
the frequency of the allele is Q, and the frequency
so much of
Phenotype is Q squared.
So change your calculation to be correct.
No, yeah, the mechanism don't make sense. It's just
I want to see.
So she just wants.
So what change are you going to make here to what you've recorded there? Because there's some stuff on your paper that's not true that we decide is not true. What's not true?
76.
I'm looking at these things. The frequency of T is 0.24, and then you said P is 0.24. Did we decide that that was true?
Oh, okay. So P. So well, remember the only. This is 0.24. This is 0.24, and this is 0.76. Yeah.
So you're telling me 0.24 is the frequency of the recessive allele? How do you know that?
That's 12 times 2 because there's 2 little t's. And so that's 24 divided by 100, which is the population. That's because there's 2 alleles per 1 person.
The only place, what you're saying is the only place those recessive alleles exist is in the homozygous recessive.
Well, in this math we are, but that's not true because you say that the tasters consist of the heterozygous and the homozygous dominant. So we take into account that.
So P doesn't equal this and Q doesn't equal this. But there are some variables up there that do equal those numbers. You guys get it? I don't know. You tell me. What did you guys do?
We are explaining to Miss Maggie what you did.
So we knew that because 12 out of 50 is 24%, we have Q squared as 0.24. And to find Q, we took the...
Is it Q or Q squared?
Q squared 0.24, and then to find Q, we...
Why is it Q squared?
Because that's the two alleles. It's the frequency of that allele. Which
That
was
allele?
The recessive allele.
The recessive allele is Q squared?
No, isn't it the genotype?
I don't know. That's what I'm asking you.
Homozygous recessive genotype is Q squared.
It says...
Y'all.
What?
Yes, it's the genotype.
It's what?
Genotype.
Oh, okay.
Genotype. Q squared.
And then we did the square root of the genotype, and we got it's approximately 0.49.
Why did you do the square root? What were you?
To find Q.
What's Q?
Q is
one of the alleles.
the recessive allele.
It is the recessive allele?
It is the recessive.
I thought the recessive allele was little t. Oh, the frequency. Oh, interesting. So then what? So now we got Q. I didn't ask you just for Q.
And so then we had the P equals 1 minus Q. So P.
Why do you know that?
Because we equals 1.
What does that even mean? What does P plus Q equal 1 mean?
It means that the frequency plus frequency of the recessive allele equals 100.
Why is that true? Why is that true? Why is the frequency of the dominant allele plus the frequency of the recessive
Because if
allele
you
1?
convert them into percentages, it has to equal 100%.
Are there any other options?
Well, yeah, if it gives you like cases, then you would do the opposite.
Are there any other options for alleles in that population for this gene? Okay. So then what?
So we have the values of Q and P. So 2Q was equal to the heterozygous genotype frequency. So we have 2 times 0.49 times 0.51 to equal approximately 50.
Did I ask you for the frequency of the heterozygous genotype? Just giving me extra information.
But it helps
Thank you, I appreciate that.
It helps us get the information we needed.
Okay, so if you were asked for phenotype frequency, that would be a good piece of information to add. What were you asked to give me? So what were you asked to give me? What letters were you asked to define? Did you do that?
Yes. So we've been done there.
Mm-hmm.
Oh, we went on to the whole percentage.